Hello, everyone. Welcome to Austin, if you're not from here. My name is Quentin Smith. I'm an offering manager in our portfolio business unit. I'm here today to announce a new instrumentation platform that NI is releasing this June, July. However, our marketing launch is this week at NI Connect. Pretty excited. It's not every day that we release a new instrumentation form factor. I think the last big push on this front was with Compact Rio, Compact DAC over a decade ago. So this signals a pretty significant shift in strategy and a new direction and new market space that NI is trying to play into. So I'm going to give kind of an overview of the form factor, or kind of some of the backgrounds as to why we are moving in this direction. And then I've got one of my esteemed partner colleagues here, Darren Lingefeld, who works at Averna, who's going to share some information around test line automation and test system integration as well, kind of towards the back half of the presentation. My intent is to leave some room at the end for Q&A. So, we're doing some intros here. I'm going to go into functional tests a little bit, background challenges on the business front and the technical front to kind of queue up, hey, why are we building this new thing called TestScale, and why are we building this roadmap, and how do we think it's going to help you guys do your jobs better? I'll give an overview as to what this new instrumentation form factor is, some of the design decisions that we've made, how it integrates into different types of systems, what the software overlay looks like. And then I'm going to hand off to Darren, who will speak to some of the system integration and line automation details that I mentioned earlier. We'll have some Q&A at the end. If something is super pressing, feel free to raise your hand or just shout at me. I have generally a pretty informal presentation style, so feel free to speak up if something comes up. And with that, I think I'll go ahead and get started here. So functional tests. So here, kind of at the bottom, I know it's pretty small. However, when you're manufacturing any sort of end device, there's often many steps that go into the final manufacture. You're selecting materials, you're doing surface mount, optical inspection, all the way through ICT, and then functional tests to make sure that the board that you manufactured actually behaves as you want it to. Historically, NI's had a pretty strong play of functional tests in certain areas, and we'll kind of go into that a little more later on. But kind of from a high level, I want to talk through some of the pressure points or some of the challenges associated with functional tests in a manufacturing capacity. So obviously, if you work in manufacturing or manufacturing test engineering, throughput is oftentimes one of the things you're most metriced by, right? You're looking at how many DUTs can you produce per unit time. And some of the details that go into that are, okay, how can you optimize the test time per DUT? Can you test multiple DUTs in parallel in a given station? Is there a way that you can introduce automation or improve upon the automation in your system to minimize the amount of idle time in your line? And then last but not least, unplanned downtime is something you want to avoid kind of at all costs, but problems arise. From a financial perspective, capital expenditures, right? So you guys have a budget that you would need to build a test station to. This budget should be inclusive of tester hardware, instrumentation, cabling, connectivity, mass interconnects, any software licenses that go into this. And typically the CapEx will scale with how many times the test station is replicated. So you have one test station, it costs $40,000. Two test stations might cost $80,000, so on and so forth. From an OpEx perspective, or kind of the engineering labor and the engineering resources, or the technician resources that go into this, obviously the effort to create that first article tester is usually significantly higher than the N+1 tester. So you might be thinking, okay, if I need to replicate a test system 20, 40, 100 times over some time period, how can I manage my OpEx over time such that the N+1 tester is not as expensive as the one before it to build? And that's something that we're going to kind of harp on here with TestScale and some of the ways it can be integrated into a fixture such that the N+1 tester can actually be cheaper and cheaper. So you're not wire wrapping connectivity, you're not buying expensive cables every time you need to build that tester. Managing changes, of course, is another big consideration. Modularity is a pro in this regard. So you have the next generation of a DUT, you have some new tests that you need to hit. Maybe you have a new measurement that you need to take. You need to write more software to encompass that. Generally, NI, we we design our tools such a way that they can scale with these changes over time, and TestScale is no exception to that fact, or that thing that we aspire to, I'll say at least. Last but not least, another consideration here, quality and reliability, something to consider. So are you actually testing the DUT to the test plan that you negotiated with your R&D team, or your quality team, or your brand team, or whoever's associated with making sure you have the right test coverage in place? Calibration and maintenance, so on and so forth. So anyway, I'm just kind of trying to cue up some gears turning in your head here around, okay, these are the things you should be considering when you're building a new test station or iterating on a test station design, specifically for functional test. So we are introducing a new form factor that is attempting to ease some of the pressures when you're scaling up your production line. So you have high levels of replication in your test system, or you're moving to a distributed test methodology, which I'll kind of go into in the next slide, but implies that you've got a different dedicated test station for any PCBA that might be in the final device, which could be comprise multiple PCBAs in that final device. So some things to consider yet again, that you can meet test coverage with stable, reliable instrumentation. You can fulfill whatever calibration or traceability requirements that you have for that test station. You want to minimize the CapEx, especially as you replicate time and time again, and that you're not over-specifying instrumentation. So you're not necessarily buying the best-in-class instrument if you don't need the best-in-class instrument to take a certain measurement and meet that test plan. Footprint is a big consideration. So, one common way to build a test station is you can buy a bunch of box instruments, rack it all up. It's not necessarily dense. It's not necessarily the most cost-effective way to do this. You've got a big rack. Racks are expensive. The bigger the rack, the more power infrastructure you have, and the cost can add up on that front. Minimizing system design and replication costs, kind of hit on that. What's the time, the first article tester versus the effort to build that N+1 tester. And then obviously, if you have some sort of software infrastructure, some sort of software ecosystem, you need to be able to integrate into that, whether that's reusing measurement code, reusing sequences that you've used in previous test stations, or plugging into any enterprise software that you might have, running analytics or controlling a fleet of testers out in the field. So really with NI TestScale, we're going to market with a new option to help you guys out with some of these pain points. Before we move on, I'm actually just going to show you what this looks like, and you'll see some pictures later on, so you can sort of see that this is a modular form factor. There's a backplane. There's 6 modules in here. There's I/O connectivity up to your DUT. There'll be some more pictures moving on. Just kind of want to ground you guys in kind of what this looks like visually. Distributed test methodology. So I kind of want to go into this is a trend we've seen. It started out in really high volume consumer electronics, but we're seeing it trickling out into other types of industries as well. So up here we've got an example of a consumer electronics device. It's a smart speaker. There's a Bluetooth interface, there's buttons, there's a power board inside there, so on and so forth. It looks like a relatively straightforward device. When you get into it, there's actually 10 or so PCBAs that are different subsystems in this final device. And what a distributed test methodology calls for and enables you to do is you can actually break out the functionality, the test functionality, the test coverage for each one of those PCBAs into a dedicated test station and minimize the amount of functionality and minimize the amount of instrumentation you need into that tester, right? So on the other end of the spectrum, you've got a universal tester, which could provide for test coverage for all the PCBAs in a final device or all of the PCBAs and all of the products that your company makes. Oftentimes there's a lot of overkill and unnecessary resources in those test stations that you're not necessarily using for any given test plan or any given test sequence, which adds to cost. So depending on your test requirements, this may or may not be the right way to go. But if you're looking at really high volume applications and you really have high throughput considerations at play, a distributed test methodology might be the right fit for your test strategy. I just wanted to call out some of the, what I would consider relatively fundamental electrical functional tests that we often see. Yet again, I called out a few of these different PCBAs. You have a main board, maybe a USB communication board. an audio jack, some digital lines testing LEDs on an LED board. Maybe there's a battery management system if it's a rechargeable device, so on and so forth. And yet again, you can break out all of the functionality or the test coverage for each one of those boards into its own test station. Yet again, not over-specify and not build too much instrumentation into that final test, or into each one of those testers. So you might be thinking, okay, well, you guys have, NI's built out a catalog of PXI equipment over the years, and you guys have used PXI. Probably many of you have used PXI, or maybe some of our other form factors for functional tests over the years. So what is this TestScale thing? Why would I want to use this? When does this make sense? The way I like to think about positioning this new product and when it might start making sense for different types of DUTs is considering two different big variables. One is volume, so the amount of DUTs or throughput, DUTs per unit time that you need to test, as well as the complexity of the test coverage. So historically, we've said, and PXI has really excelled well if you're in a relatively low volume application. So, with high volume, you're looking at tens of thousands of DUTs a month, upwards of that. It's different for everybody. There's big consumer electronics companies out there that are gonna push that definition, but you're talking about thousands of DUTs a month, considering that kind of high volume in this sense. So yet again, volume and then test coverage. So PXI has historically played well with more complicated tests. You have higher channel counts. You need as much performance on each one of those pins as you can get. You might need big switching matrices, so on and so forth. But there's a lot of applications out there where you don't need that same level of sophistication. You don't need that same test coverage. And frankly, PXI is an overkill form factor and an overkill set of instrumentation for those applications. So if we think about still relatively low volume, but pushing up into simpler tests, historically, there's, PXI DAC has been maybe a good option, maybe PC-based DAC, maybe a PC-based DMM, some external switching, so on and so forth. And then when you get into kind of higher volume applications, and specifically higher volume and really simpler test coverage applications, you're looking at PC-based DAC and really cutting as much cost out of each one of those instruments and each one of those channels as you can. So given that, what we're releasing today, and we're going to go into some more of the details, we're not trying to say, hey, this is going to take over our PXI catalog or anything like that. We're really trying to position and build out this form factor in such a way that it can be adjacent. You can think about it as an adjacent instrumentation option for PXI, depending on what the test coverage and what your production line actually looks like. I think that's an important distinction. You can think about it as, hey, you've got another tool in your tool belt, another set of instrumentation, another part of our catalog that you can go to fulfill different parts of your jobs. So with that said, I'm going to introduce TestScale. So I already showed you a physical version, so you can see, relative to size, what this thing looks like. I'm holding it in my hand here. Some of the big things I want to call out is we are, where do I want to start here? So it's a modular form factor, first and foremost. So that's probably not new to anybody that has used NI equipment before. We like modularity. We like the benefits of modularity. It enables you to expand channel count in the future. It enables you to swap out modules depending on what you need. We're starting out with a variety of some analog input, analog output, digital output, and a programmable power supply channel. I'll share more on the modules later, but there's additional items in the roadmap coming to kind of fulfill this electrical functional test value proposition. One big innovation, or one big set of innovations that we've really leaned into here with TestScale is the ability to deploy the instrumentation inside the test fixture. So I kind of alluded to this earlier, but this guy is designed to mount into the test fixture in a couple different ways, either to the fixture pan or potentially up to the interconnect board. And we'll share some more images and some other details to that kind of prove out that point. With that said, we also have a form factor available for kind of a more traditional standard rack mount approach if you want to connect out to a mass interconnect or use longer shielded cables to get up to your DUT. This is a USB connected target. So we've got a USB hub on the backplane There's an upstream-facing port to tether back to your host PC or Linux box. There's 2 downstream-facing ports to daisy chain potential multiple backplanes in either a daisy chain configuration or star configuration. Or you could connect out to peripheral USB targets, peripheral USB devices, whether you need that USB CAN module that NI sells or a third-party box instrument over USB. One of the value points here is, hey, we really want to minimize the points of connectivity back to your host PC, as that can get kind of messy with all the cabling and whatnot. Footprint, I kind of alluded to that. We'll kind of go into that some more. Another big item I want to hit on is we're standardizing on a 37-pin D-sub connector for really simple mating and connectivity. It's very easy to find off-the-shelf components for a mating connector here, cheap ribbon cables, cost-effective shielded cables, or if you're kind of making an interconnect board to mate with TestScale, you really get the benefits of that modularity in the mix and match. So you often see a full PXI chassis, for example, 18-slot PXI chassis. There's 17 I/O modules, and every module inside that's got a different connector. And you've got a pretty advanced mass interconnect to connect out to that. If you switch one of those modules in, that leads to downstream changes in your system and all the connectivity. So really standardizing on that connectivity and providing sort of a uniform bulkhead interface type situation is something we wanted to lean into. The last thing I'll hit is that this is a cost-effective solution. So I've got some pricing information in here. We're releasing the hardware in full later on in the summer. It is a more cost-effective approach to PXI. With that said, we're not going to have the same level of performance instrumentation that we have in PXI, going back to kind of the fundamental market position that we're trying to achieve here. So now I want to kind of harp on kind of some of the form factor considerations and the deployment and mounting considerations. So over here on the left, you can see what we're calling our in-fixture variant. This is what I'm holding in my hand. The idea here is that you can mount this thing into a fixture. I've got some pictures further on, but there's actually a demo that one of our partners, Circuit Check, helped build out. That's down on the demo floor right now. Call to action. If you guys are interested in this, you can go see a pretty nifty demo with some pretty nifty lights and some functionality, LabVIEW test stand, all the things that you're used to running in here. So this thing can either be mounted to the fixture pan, so kind of just to the bottom of the fixture pan like you're sitting on a table, and cabled up to your interconnect board, or you can take the I/O connectivity and actually mount it directly up to the interconnect board, completely removing the need for I/O cables in your system. Kind of go into some of the benefits of that, but yet again, less cost, fewer cables, fewer points of connectivity, fewer impedance mismatches, and cables are something that fail and they're kind of hard to troubleshoot from time to time. So something to consider on that front. With that said, we've also got kind of a rack mount form factor. It's a 1U half rack width enclosure. We provide the enclosure. We provide a fan to keep everything cool. And you can kind of think about that as, hey, in 1U, you can get 12 slots of TestScale and kind of mix and match and kind of make like a custom 1U instrument, if you will, on that front. The connectivity, the USB and power connectivity runs through the back of the enclosure, so up into the guts of the rack in that context. Here we're showing just some of the benefits of why you might want to mount in the fixture. Yet again, I think the big one, and I think this might resonate with a lot of you guys if you've ever troubleshot cable problems or what's going on with this connector, what's up with this bent pin. The shorter the connection path, the shorter the path of passive connectivity inside the test fixture, the less room there is for issues, the less signal degradation that happens. You get the instrumentation as close to the DUT as possible. In time, we want to build out some switching, get the switching as close to the instrumentation as possible. There's a lot of benefits from a cost and a performance perspective by designing on this front. But with that said, even if you are still not necessarily mounted directly up to the interconnect board, you're mounted somewhere in the fixture pan and cabled up, you still have a shorter cable path. And you get those signals up to your DUT as quickly and shortly as possible. I'm not saying that there's never going to be a use case where you might want to rack this up or mount this up in a rack, and we're still going to support that use case. But we think it's a slightly less differentiated and kind of a less interesting play But you can still integrate into existing architectures, integrate into existing interconnects that might be modular, where you can add new connectivity modules. Here's just sort of an exploded view of the demo we have downstairs. So you can see what you're looking at here is essentially the guts of a fixture. TestScale is mounted directly up to an interconnect board that goes up to some pogo pins, and then your DUT is on the other side. So the demo that we have is a 2-up system. So there's 2 DUTs being tested in parallel. And again, you can see the size, the footprint, and the connectivity. Yet again, getting the instrumentation as close to the DUT as possible. I want to take a few minutes and just kind of talk through I/O, right? We've been talking about form factor, we've been talking about positioning a little bit. Like at the end of the day, you need to take measurements. So what I'm going to harp on here is sort of the first phase of modules that we're going to be releasing. There's going to be more modules to come. So if you guys are interested in talking about what's going to come in the future, I've got some business cards up here. I'd be happy to exchange my email and kind of take some of this offline. But this isn't going to be a full roadmap discussion. Effectively, what we're starting with is some foundational measurement capabilities for electrical functional tests. So a multiplexed analog input module, a simultaneous analog output module, so the analog input module 32 channel, analog output module 4 channel, a 32 channel bidirectional DIO module that's capable of 3.3 or 5 volt logic, selectable by the user, and then a higher voltage up to 60 volt 32 channel syncing output digital output module for driving bigger electrical mechanical components that might be in the rack or syncing power to ground, driving bigger relays, so on and so forth. Interestingly as well, we're releasing a programmable power supply. So this is something that's different from some of the other DAC-oriented form factors that we have, where there's not actually a way to power on the DUT and take current and power measurements while the DUT's doing different things in different states, and you can characterize and put limits around power consumption. So starting with a 6 volt, 3 amp, 18 watt power supply, yet again, it's capable of voltage and current readback, so you can take power measurements. Power equals current times voltage. There's remote sense, so 4-wire measurements with closed loop control, protection. All of this capability is supported in NI DACMX, which is a sophisticated and mature API that we've built a lot of products on in the past. We'll have support in C, LabVIEW, .NET, Python, Windows, Linux, probably some more stuff in the future. The idea is that you can use this instrumentation with existing test systems and existing test architectures that you guys may have in place. I kind of jumped the gun here, but just kind of wanted to call out how this kind of plays into a larger software stack. There's nothing, from a software perspective, there's nothing particularly unique about TestScale compared to some of our other instrumentation form factors. So yet again, it's supported in DACMX. You have a wide variety of APIs that you can program in. In time, we're looking at building out support in Instrument Studio, which is an interactive desktop tool where you can do interactive bring up, start exercising your DUT, start cutting your teeth on measurement capabilities and exercising the DUT in that way. We're also leaning into, and this is kind of a broader NI statement, but providing support in common Linux distributions and not just Windows. And that's a piece of feedback we've heard from you guys over the years, something that we're certainly leaning into in this space. So we know Linux is becoming more and more popular on manufacturing floors in particular. I want to go back a little bit to competition and positioning here. So, you guys imagine your manager asks you to build a new test station or retrofit an existing test station. You guys have a lot of options for what's out there in terms of how do you select the right instrumentation, more or less. There's PXI, there's NI DAC, there's other DAC vendors, there's Box Instruments, there's custom solutions depending on the type of company that you are. There's cheaper board level solutions oftentimes being sold out of APAC, for example. It's important to think through which of these variables is really important for you and which are you trying to optimize for in your test station design. Some of the things that we really want to call out regarding TestScale is yet again footprint. Really shrink down the size of the instrumentation, potentially remove the need for a rack completely, remove the need for a lot of the bulkier test system hardware that you might need to buy. What about test software integration? Like, do you trust the API of that device that you're building? Is it from a reliable vendor? Is it fully featured? Does it provide support in Python? Does it provide support in Linux? So on and so forth. So, you can kind of review this. I think everybody's going to have a different take on, how they would pursue, selecting and comparing different instrumentation platforms. But yet again, kind of the two ones I really want to harp on are from a price perspective, keeping things cost effective, as well as a footprint perspective, and kind of thinking about an in-fixture approach to the test. And with that said, we, NI, as you guys know, we are experts at building instrumentation and building driver software and test application software, but we are not experts oftentimes at building fixtures and automating production lines, which is why we have a really robust and reliable partner network that we can rely on and we can point you guys to for final solutions. So specifically with TestScale, we partnered with 3 partners in particular. Booster's got a pretty large presence in the Asian region. Averna, who is co-presenting today, as well as Circuit Check, to kind of give us feedback on, does this concept make sense? Does this footprint idea make sense? Like, how do we actually connect this stuff up to these interconnect boards and give them early access hardware so they can build out their own engineering teams and their own mindset towards how do we actually go and take this instrumentation and work with end brands or end manufacturers to actually go and build test stations and build real stuff and get this stuff onto your manufacturing floors. And with that said, I think I'm going to hand it over to my esteemed partner colleague, Darren here.
Hello, everyone. My name is Darren Lingefelt, and I'm with Averna Test Systems. I've been in the test industry and around National Instruments for about 25 years now, so quite a period of time. And one thing I want to mention about TestScale that I find interesting is if you've been around this world long enough, you realize this is really kind of the first new hardware platform NI's done since C-RIO and C-Series. And if you were part of the world that long, you remember what a relief CDAC and C-RIO was to the industry in a way, because packaging PXI was not always easy and it wasn't the right form factor for many applications. And I think this is interesting too in the same way, because it offers us a new way to solve problems. A little bit about Averna. We're one of NI's largest partners. We've got 9 offices around the world. We're headquartered in Montreal, office that I'm from on the East Coast in Charlotte. I manage sales and operations for the Eastern America and Canada region. My colleague here, Jim Carahan, in the audience, is out of our West Coast office. He handles Western US and Latin America. We also have offices in Europe and Belgium, Netherlands, 2 offices in Poland, and office in Japan and coverage in Asia. Across those offices, we have 400 employees. 300 of them are on the execution side, designing, building, assembling, and deploying test stations. And that global reach allows us to build stations in volume, work closely with our customers and market, and support systems that we deploy. Our primary business is designing and deploying custom tests and manufacturing systems. And our ideal project is to work with a client on a first article test station. Maybe it's MPI or something like that. Design that first station and then duplicate it 10, 20, 30, 100 times. That's why we like the idea of TestScale. It really is a good platform from a form factor and a cost perspective for volume test station deployments. And to do volume test station deployments, you need a big group of people with a lot of skills, which is represented on that lower line. Another thing I like about TestScale is the simplicity of it that it's going to bring to our designs. When you're designing a test station, early on in the process, it involves a lot of electrical lift to do the schematics. for that and some mechanical lift. And for every, and one thing I have to impress upon my guys is let's reduce the connections, because every time you pass a wire through a point, often I've found that's where the failure happens, and it's really hard to diagnose. So when you draw that wire in a schematic, you're creating work for the electrical designer. They have to think about a bulkhead connection they're going through. They have to think about how they're going to rate the wire for that, rate the pins for that. And every time that line and that connection exists on a piece of paper in a schematic, then somebody on the floor has to wire it correctly. They have to label it, they have to terminate it, they have to do all those steps. And then they have to validate it at the end before it can ship. And those are all possible failure points that may or may not add value to the total solution. So TestScale can reduce that. It can reduce the cost of designing something because you can connect closer to the DUT, device under test, and it can reduce the cost of building something because I've got less wiring in the system. I'm going to move the instrumentation next to the device under test. Averna works across a lot of different industries, and the advantage of that, not being siloed in one place, is you can bring best practices back from different industries and apply them with the client you're working with now. We are excited about TestScale in consumer electronics and automotive and high volume life sciences. Think about wearables, think about diabetes monitors, stuff like that. Low cost, high volume. So a lot of good applications there. And if you work in this industry long enough and you work across a lot of these verticals, you start to see reoccurring themes and tests that you can apply in different ways. So we work with clients to develop standardized test stations. And if you're like me, you're from North America, most of your test stations are probably manually loaded rack and stack affairs where you're clamping a device under test into some sort of fixture. If you're from Europe, like our European colleagues at Averna, most of your test stations aren't manual, they're fully automated. The DUT is not handled by a person. And that's given us as a company the ability to kind of leapfrog where we're going next in industry. So we're not just working on standardized test platforms now. We're looking at how do we standardize a line and how do we reuse as much of that as we can in a form of a platform. Recurring themes that we've seen in industry over the last 2 years, a lot has come from EV and electronics around EVs and ECU modules in general. We started seeing RFQs with the same sort of requirements for test. And in Europe, a lot of automation around it. We want hands-off handling of the DUT. But we just can't design a bespoke automated inline test station for every client and be competitive in the marketplace. So we had to recognize where's there some reuse that we can apply. And through our interactions with EV tier 1 suppliers and the fact that we kept seeing recurring themes in tests, like we want to do a functional test on this device, we want to then do a high pot test, maybe a leak test if it's water cooled, and then some visual inspection of connectors and whatnot, and maybe laser marking. So how do we design, an inline station that can do all of those things? And some of those steps may take 3x the time. So I may have to have 3 of those in line to manage a balanced takt time through the process. So this morning in the keynote, you may have seen a video for a new platform we launched this year based on that actual experience from the marketplace called Uniline. And we plan to integrate TestScale inside of this because it's a great form factor for it. So let's let this video start up and you'll be able to see what I'm talking about. We've taken a mechanical design for a station. We've standardized on the DUT handling and conveyor systems around it. We found that, particularly with EV electronics, that a lot of things tend to fit in a given form factor. And if you can just say, I'm not going to design an egg-laying milk pig that can cover everything, but I will cover maybe 80% of the stuff that I'm seeing from a packaging perspective. I can get an envelope for a product, and I can design sort of a platform standard and a pallet standard to bring it through. So we've got that standardized. This should then reduce the cost to our clients because we plan on reusing this same platform again and again. We see TestScale fitting in high volume, low cost situations because as we saw in the animation, we can bring the instrumentation really close to the DUT and reduce the wiring, the design effort, and scale much more easily. So that's our Uniline platform that we introduced today. It could support a variety of standard instrumentation and PXI. In fact, the first implementation was PXI because this didn't exist yet. But we definitely see this integrating into that platform as we move forward. And if you'd like to learn more about it or discuss it with us, feel free to stop in downstairs to our booth. Thanks. I think we'll open it up for questions now.
Yeah, we got, I don't know, 8 minutes or so for questions, I think.
Quick one is that, is the module calibratable?
Yeah.
Calibration cycle that's like the module.
That's right. So yeah, so we'll have 2-year warranted specs up through ISO 17025 accredited calibration, and provide documented cal routines as well as cal exec support. So depending on your industry, that may or may not be important. We're also planning on having longer typical specs if you don't necessarily need the calibration paper trail to get away with not calibrating, but still feeling confident that you're reliably testing your DUTs. Oh, yeah.
If you mount this to an interface board, does National Instruments supply the footprint for that PCB interface board?
Yeah, so this is something that's come up a few times. Like, I think maybe what you're asking is like, could we provide some sort of layout file or some sort of...
And how it's mechanically connected and all that, yeah.
Yeah, so we'll have a lot of that documented. I'll take this back to the R&D team because we've heard about this a few times. So I want to make sure we've got something that's readily downloadable and that you guys can uptake immediately. But yeah, I think that should be something that we provide out of the gate. Yeah. Question?
So I guess, this particular solution being made to go so close to the DUT and the fact that a lot of, semiconductors, because of the automotive industry, kind of have to be tested across temperature, or what are, the considerations for that with this device?
So, well, the operating temperature range will be 0 to 55 degrees C, so it's not necessarily meant to be put into a high temperature thermal chamber. We have some other instrumentation platforms that are better for that, that have a higher operating range. Does that help answer your question, or were you asking something slightly different?
It's fine.
Oh, if you want to rephrase that, I might have misinterpreted.
I'm taking your answer as if you want to test across temperature, it's better to use something else rather than this.
Well, I mean, you could.
Is there practices for mounting this for use, not putting it inside a temperature chamber, but maybe with a thermal stream, or are there
Sure.
or protections best guidelines for that kind of thing?
Yeah, so we'll have documented shock and vibe and environmental conditions specified. At the end of the day, we provide holes for mounting, as well as the rack mount version will have kind of a front panel that you can mount into a 19-inch wide rail system. So there's a lot of flexibility in how you could mount it. It doesn't necessarily need to be in a fixture or in a standard ATE rack. And you can vary temperature.
I think if you're doing hot type testing, probably the instrumentation staying out of the war zone inside the environmental chamber too, usually. So maybe it's not the right platform for that.
Yeah.
Do you have multiple of these running in a single system? Like maybe 4 of these if you need a large number of principals?
Yeah, so there's a USB hub on the backplane, so you can actually daisy chain, I think up to 6 backplanes. I need to double check, but you can daisy chain multiple backplanes to expand the number of slots that you have, and then mix and match the different modules to reach whatever I/O count and type that you need.
You wouldn't lose performance for doing that? It's daisy chaining them, it would maintain the same performance?
Yeah, so the same measurement performance will still be handled by the module, and it's just that the connectivity over USB is communicating to and from the host PC, so you wouldn't lose measurement performance in that configuration.
I think the USB hub's a nice feature too, because like if you're going to do an in fixture, you're probably going to have, you could have some programming devices or something that it's USB, and it's one less device you have to put in there. I mean, you typically will find a USB hub in the basement of a fixture.
Anything else pressing? Yeah.
You were mentioning it was a cost effective report. What's the cost savings?
Yeah, so depending on the module type and mix that you have, you can look at a system like this and looking around $5,000.
Oh.
Yeah. No problem. No problem. Yeah. Yeah.
Does this show up in Max in about the same way as a Pixie chassis, or?
Yeah, right. So the backplane will show up in Max, and you can expand the backplane out and see the modules in there. You can self-test, reset, rename aliases, do all the common Max features. Yeah.
This is a product owned and supported by National Instruments, not by Vernal.
That's right. Yeah. So if you run into challenges with the instrumentation or the software API, that is generally an NI support issue. I know sometimes the line can be a little gray if it's something in the test system seems to be failing, and we may have to get somebody like a Vernal on the line as well. But this is a NI developed, manufactured, and supported platform, both from a hardware software calibration services perspective. Yeah. I'm scanning.
In the future module, besides the one you showed, that you can give us a hint of what's coming up, or?
Yeah, I mean, I don't think it's a huge surprise. I mean, I think where we want to go is more power instrumentation, as well as maybe a higher performance, flexible DMM channel with some switching, and then a variety of other AI, AO stuff in the future.
Floating ground AI, maybe?
Floating ground AI. It sounds like you've got a need for floating ground AI.
And one thing I've asked for is 24 volt DIO, so you can run directly industrial level stuff. When they introduced it to us, another question my guys had were, okay, well, when do I use this versus a CDAC in a test station? And obviously their minds were, can I put this everywhere? And Quentin made a good comment to me earlier today, how he's differentiating it. If you're doing sensor tests, or there's electromechanical measurements you're making, maybe there's forces and stuff like that involved, it's probably a CDAC. And that got me thinking, yeah, most of those test stations that are electromechanical in nature, we're usually designing a pretty big mechanical frame. There's an EMA enclosure that houses all of our electronics, and it sort of lends itself to that form factor versus this, which is more volume production.
More focused on electrical instrumentation.
And electrical
measurements.
Good questions.
Yeah. All right. Well, I think we may wrap it up.